Good evening, everyone. I am Dominus Orbis, and today I'll be doing Packet Tracer 4.2.1.4, configuring static frame relay maps. Now, frame relay is a serial interface WAN protocol, and it's preferable to point-to-point protocol, PPP. The benefits are greater bandwidth, reliability, resiliency than private lease lines, and it's also more cost effective. It uses virtual circuits as opposed to physically connected circuits. And the layer 2 identifiers are called DLCs, which means the data link connection identifiers, and they are locally significant. And then frame relay also relies upon the LMI, local management interface, which is the definition of the messages used between the data terminating equipment, the data circuit terminating equipment, and the data terminal equipment, or the frame relay switch for the data circuit terminating equipment. Okay, let's go ahead and look at the topology here. Here's the frame relay switch. Got 3 branch routers, the internet web server, and let's look at the instructions. 2 static relay maps, as opposed to dynamic, which would be using inverse ARP, which we'll learn about in another packet tracer. Okay, configures frame relay encapsulation on R1 serial 000. This packet tracer is very simple. Remember, the default encapsulation for WAN is HDLC. And let's go ahead and do all the routers serial interfaces with the frame relay. You can verify that by using the do show interface command right here, encapsulation frame relay. And then on router 2 as well. From the PC, verify connectivity to the laptop. It should fail because they don't have a route to reach this network. R1 must be configured with the frame relay map so it can find the next hop. PC to laptop. Alright, let's check it out. Unreachable. Okay. Configure static frame relay maps and the LMI types. There's more than one type. We're going to talk about that in a second. 2 static maps to reach the other routers. The DLCs to reach these routers are provided. They will be provided by your ISP. I think the range is 16 to 1007. We're going to find out here in a second. Going back to R1, the command is frame relay. Just use the help. Map IP. Okay? This is going to be the remote IP. The 10.1.1.2 is going to be router 2. So we're mapping router 1 to router 2. The DLC is 16 to 1007. That's the range. 102. And then broadcast keyword allows dynamic routing protocol updates such as EIGRP and OSPF. And then we also need to create a map for router 3. And that delc will be unique. There we go. Going to R2. So, gotta look at the topology here. It's the same interface. Okay. Frame relay map IP to router 1 will be the 10.1.1.1, and the delc will be the 201 according to packet tracer. Don't forget the broadcast keyword, and then map it to R2 to R3, and the delc will be 203. It should be, yep. And the IP, the remote IP of R3 right here is the 1.1.1. Sorry, the 10.1.1.3. There we go. Now moving on to R3. Set the 000 interface here. Frame relay map IP .1.1.1 delc 301 broadcast, and then the same for router 2. Just change the delc and the IP. There we go. These are static relay maps. Now we're going to change the local management interface type. Options are ANSI Cisco Q933A. We're going to use ANSI on all three. R1, R2, it's an industry standard instead of the Cisco proprietary. And then R3. There we go, adjacency, adjacency, adjacency. Got 100% here. Should be able to ping now from the PC to the laptop. Oh, I'm supposed to ping the web server. Either way, I can get through to the laptop. Here's the PC to the web server. There we go. And then the laptop. To the web server. And it looks good. Once again, I am Dominus Orbis. I hope this video has been informative, and I want to thank you for viewing.